4.5 talks about graphs of the other trig functions. So part 1 here starts out with tangent. Now tangent we have to be careful of because remember, tangent is y over x. We didn't have to worry about this part now here with sine and cosine because they were either y over r or x over r, respectively. So r was never going to be 0. But when you have y over x on your unit circle, sometimes x is 0. And we can't have 0 on the bottom of the fraction. So we're going to have some asymptotes in this one. So our period's going to change. Our period for tangent and cotangent is actually pi. It takes a little shorter cycle before it starts repeating itself. So let's go ahead and let's create a parent table for tangent, and then we'll be able to graph it. So we're going to start out with negative pi over 2. And since that's period is going to be pi for tangent, we're going to end at pi over 2. And so again, I'm going to use my intervals. So halfway between negative pi over 2 and positive pi over 2 is 0. Halfway between negative pi over 2 and 0 is negative pi over 4. And halfway between 0 and pi over 2 is pi over 4. Now, remember, at negative pi over 2, that's at the bottom. It's at it's the same as 3 pi over 2 if you used your coterminal angles. And so its ordered pair is 0, negative 1. Well, that means that x value is 0, so this is going to be undefined. And then at negative pi over 4, that's the same as 7 pi over 4. So it's going to have an ordered pair of square root of 2 over 2, and then negative square root of 2 over 2. So if you took your y over x, you would get negative 1. Then 0 has an ordered pair of 1, 0. And so if you take your y over your x, you get 0 over 1, which is 0. And then we can keep going around. Pi over 4, we take its y over x. We'll see that it's positive 1. And if we take the ordered pair at pi over 2, and we take y over x, we'll see that it's also undefined, because x is 0 there. So let's graph this. So at undefined, at the negative pi over 2, we're going to draw in a vertical asymptote, and the same thing at positive pi over 2. And then graph your points in between. So negative pi over 4 is negative 1, 0, 0, positive pi over 4, positive 1. Almost looks like it's going to be a linear line right there. What happens when you get close to that asymptote, it's going to force your graph to curve. So it really kind of almost looks like it's a cubic. It's that little squiggle like a cubic has. But now remember, that's just one period, and it can repeat itself. So we could keep going here using the pattern and create another full period. And then we could have went the other way and still used our pattern to create another full period. Alright, so looking at that graph there, let's kind of go through what it's talking about. So it talks about the domain. Well, the domain is obviously not going to be all real numbers because we have asymptotes. So what we're going to do is we're going to specify actually where, the way they wrote it's really weird. So let's just say, okay, well our x values cannot be, we'll find an asymptote. So negative pi over 2 was the first one that was in our table. So x cannot be negative pi over 2. But now remember, this is only what I graphed right here. The graph actually keeps going and going and going. So notice, every so often we have an asymptote. How far apart are they? They're actually pi apart. So we're going to say plus pi n, where n is going to be an integer. Alright, and the reason we say plus pi n, because then n could be 1, which would give us give us positive pi over 2. N could be a negative 1, which would also give us a negative 3 pi over 2. N can be any integer, which remembers our counting numbers. Negative 2, negative 1, 0, 1, 2, 3, 4. It keeps going in both directions. Alright, and then it talks about the range. Well, notice on the range, our graphs do keep going up. They do keep going down. So it's negative infinity to infinity. Our zeros, where it crosses the x-axis or the x-intercepts, Well, let's pick one of them. So, first one I see that was on my table was at 0, 0. So you would take where that's at, and you would add how often are they happening. Well, how far is it from 0 to the next one there at pi? It's happening every pi, so we say pi n, which really 0 plus pi n is just pi n, where n has to be any integer. Okay, for vertical asymptotes, well, our vertical asymptotes are where our domain is not. So we already said where the domain could not be, so the vertical asymptotes are at the pi over 2 plus pi n. Is it even, odd, or neither? Well, I believe we talked the other day about that a little bit, and we said only cosine and its reciprocal are going to be even. Therefore, tangent has to be an odd function. So what that means, it's symmetric to the origin. But it also means that if I take tangent of negative x, that's going to be equal to the tangent of positive x, except the sign in front of it's going to change. And then we had already stated that our period is equal to pi.